Okay, so did you guys finish up that parabola work?
No.
That's tough stuff. Did you make it through all those?
I've been to work.
Yeah, they're tough, huh? All right. Where are we? Today's the 23rd. All right, so we're doing 10.3, 10.4. Right. Yeah. Exam is supposed to be next week, Monday, Tuesday, right? Raul doesn't want to have it on Halloween.
Mm-hmm.
So we should do whatever Raul wants, really. No, I'm just kidding. But we are going to move it, but not because Raul wants to, but because we're a little behind. We need a little more time. So the exam will be next Wednesday, Thursday. Let me write that. Exam number 3.
First and second?
Wednesday, Thursday, right. November 1st, 2nd. There it is, 1st and 2nd. So practice exam will be this Thursday, though. Monday. Tuesday, I'll move on with new stuff. Wednesday, Thursday is the real exam. So we'll start the practice exam this Thursday we'll take it on Thursday. I'll go over it on Monday. You'll have the day in between Tuesday where I'll have to go on to new stuff, but you'll have a study day, and then Wednesday, Thursday of next week is the real exam number 3. All right.
You earned those 5 stars on Rate My Professor.
Oh, good. That's really important to me. Okay, so let's get going. So ellipses. So ellipses are egg shapes, basically. Egg shapes, like circles that are squished or tall, And really, this is going to be easier. If you made it through the parabola, you're in good shape. Parabola is the hardest by far. These last 2 are much nicer. Let me give you the general formula for an ellipse, and a hyperbola is almost the same thing, which is nice. So here's the formula for ellipse. It looks like that. So totally different than the parabola formula, right? Which had the 4 and the A and the stuff like this. So this is generally what an ellipse formula looks like. Hyperbola is the same thing with a minus in the middle. The next section, 10.4, almost identical. Only difference is it has a minus in the middle. And notice it has a 1 on the right side. That's key for both this section and the next one with the hyperbola, is 1 is on the right side. So that means, we'll talk about that as we see examples. So what's the A and the B? Well, they're how wide and how tall the thing is. So in other words, you look at this, when you make your actual ellipse, this is over positive A, back negative A, up positive B, down negative B. It's basically how, whatever's underneath Y is up and down, because Y is up and down, and whatever's underneath X is right and left. So let me just say right from the get-go, don't be confused by the A and the B, because what will happen is as they bring these formulas out and as they start moving things around and trying to fool us and changing things up, you could get confused on the A and the B. And you start thinking, okay, A is always with the X and the B. No. A is not always with X. B is not always with Y. Don't try to track it that way. It'll get too confusing and it'll feel like a shell game. They're constantly moving the thing around on you. It's hard to track it. Think this way. Whatever's underneath X, call it A, call it B, call it Joe. Whatever's underneath X is right left. Is here and here, because X is right left. It's how wide the ellipse is. And whatever's underneath Y, whatever you call it, is up down, because Y is up down. That'll work for you. Just track with that. That's always true. Whatever's underneath X is right left. Well, the square root of it, huh? Because it's A, not A squared, so you got to root that, whatever's there. So, for example, if they give me X squared over 4, I'll root that and I'll go, oh, it's right and left 2. It's 2 and negative 2. Does that make sense? Yeah. I'll just root the number. Whatever's underneath Y, say they give me a 9. I'll go, oh, root that. It's up 3, down 3. The root of whatever's underneath X is right left. Whatever's underneath Y is up down. That's how it's going to work. That's the main part. It's pretty easy. So let's clean this up. So looking at the picture, so they're having me work backwards. They're saying, all right, here's a picture. I don't know if you can see that. It's not very big. Let me make it a little bigger. How far? It looks like it's going, if you can see it at all, looks like it's going right 3 and left 3. So 1, 2, 3. And 1, 2, 3. And then how far up? 2. Looks like 2. So 1, 2, 1, 2. So it's kind of funny. So it's doing this. I'm a pretty I'm a pretty good drawer. You've probably noticed, right? I got a C in art in intermediate school. That was the end of my art career. I was trying too. So anyway, so let me know if my drawings are too sloppy and you can't read them. I'll tell you what it should look like. So 3 and -3. This goes over to 3 and back to -3. Up to 2, down to -2. So therefore, from that picture, let's come up with the equation. We know it's, x squared over something, y squared over something equals 1. So what's underneath x if it's right 3 and left 3? 9, because it's squared, huh? What's underneath y if it's up 2, down 2? 4, because it's those numbers squared. So which one is that? B? Yeah, B. Looks like B. There it is. Is that good so far? Ellipses are easier than parabolas because you don't have to worry about going 4 different directions. That's what makes parabolas the hardest, right? They can go left or right or up or down. They can do all kinds of things, and that makes them harder. Also, notice that both letters are squared for the ellipse. It's going to be the same thing for hyperbola. Notice you don't have one for, right? Remember parabola? We would have like y squared is minus 4ax or something. X would be first power, y would be second, or vice versa. One letter would be squared, the other would be first power. That's why there's only one branch on a parabola. But ellipse, they're both squared, so it's 2 branches that get together to make that egg shape because they're both squared. That's what's happening. Okay, so that's how you recognize them on the test. Okay, let's keep moving. Let's see. Okay, so they're giving me an equation. It's always best to start with a graph. I think graph just makes everything else easier. Let's go to the graph. So can you graph that? You know it's an ellipse just by looking at the general look. So 49, underneath x is 49. So square root of 49, 7. Underneath y is 16, square root of 16, 4. So what's underneath x is right and left. So 7, -7, underneath y, 16, 4, -4. And draw yourself an ellipse. Like that. Egg shape. Looks like a football or a blimp or something. All right, so there we go. Is that good so far? Now, that they want the picture, they want the coordinates of the vertices. What are those? These 4 points. These are all, well, I think, or is it just the main 2? So this is 7s. I forget the details sometimes. This is, let's see, let's go back to so when they say vertices, what they mean is they mean the biggest 2. So, well, here, the vertices is this one and this one. Now, it's not always the x. Sometimes it's the up-down. How do you know which it is? Whatever's bigger. Whatever. So if the ellipse is wider than it is tall, then the vertices are the right and left edges. If the ellipse is taller than it is wide, then it's the top and the bottom. So vertices, let me write that. Vertices are longest edges. Does that make sense? If it's taller, then it's the up-down edges. If it's wider, then it's the right-left edge. This one's wider, so the vertices are just the -7, and the 7, Either order, doesn't matter. List the 2 points that are the edge points. So it's the largest edges. Those are the vertices. Okay, now, there's something called the focus points. The plural of focus points is foci. So what are the foci? What are the 2 focus points? Well, the focus points are always on the biggest axis, what they call the major axis. Meaning, again, is this ellipse wider or taller? Well, this one's wider. So this is the major axis. The other one is the minor axis for this ellipse. If the ellipse was taller, then the major one would be the up-down axis. So the foci points, first off, always lie on the major axis. Where? Where do they lie? They lie, you can find them, from the Pythagorean theorem. Well, almost. A different version of the Pythagorean theorem with a minus. C is the foci points. So remember, for the parabola, we had one focus, because we only had one branch. We have two here. Because we have two branches, we have two focus points. Two foci. So it's going to be like here and here, roughly. I'll find the numbers in a second. But basically, they're going to be equidistant from the center on the major axis. It's going to be plus C and minus C. They're the two focus points. How do we find them? We use the Pythagorean theorem with a minus. That's basically the Pythagorean theorem, right? With a minus in between. What's the A and the B? Well, the A and the B are, the A squared and the B squared, are the numbers underneath X squared and Y squared, right? Remember that? Like that? Now, here's where, if you click on the Show Me an Example button, it just gets really confusing. Math Excel says all these things about it's A squared minus B squared, but sometimes it's B squared minus A squared, and it depends on the blah, 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 blah. It's just hard to memorize all that and keep all that straight. Instead, I suggest to you, logic is always the better way to go in math and science than trying to memorize 10 million different things. Just look at this. I've got to subtract two things. When you subtract two things and the answer is positive, right? Because C squared, that's positive. It's squared. Something squared is always positive. If I'm going to subtract two things and the answer is going to come out positive, I got to put the bigger one first when I subtract. Call it A, B, Joe, or Tom, I got to put the bigger one first, don't I? So when I look at 49 and 16, who's going first? 49. Yeah, just do that. That's easier than memorizing all their silly rules about stuff. It's basically the major axis that goes first. It's wider than it is tall, so it's X in this case, equals C squared. Solve for C. What does that mean? What is 49 minus 16? 33? 33 is C squared. So what's C? Root 33, plus or minus root 33. So then this point here is plus root, kind of run out of room, huh? This one is plus root 33, comma 0. This one minus root 33, comma 0. And we're done. Those are the two focus points, the foci.
Is it always going to be between the center and the...
Yeah, it's always inside. You're right. Good question, Barbara. It's always inside between the center and the edges. Yeah, it's never outside. It's never beyond, never outside the shape. Well said. Yeah, and that's the same as for the parabola. Remember the parabola? The focus points were always inside the satellite dish, right? The little receiver is always inside. Same thing for the two half branches came together to make an egg shape. The focus points are always inside. That's true. But if this one was taller than it is wide, then the focus points would be up and down, wouldn't they? On that. Is that good? Questions on that? Okay, I never have time to do some of the things that I would like to do. So I'm going to take 1 minute maybe and say, what are focus points? I don't like to just throw out math facts without reasons. what are those two dots? You know what they are? Well, you know what an ellipse really is? If you take like 2 points, just any two nails on a board, let's say, okay, those are the focus points. C and, minus C and plus C, whatever. And then you take a string and you tie it to both those. Have you seen this before? Yeah. You tie a string, let's just say a loose string, right? And then you take a pencil and you pull it tight. So let's say you just pull the thing tight and you put your pencil right here and you start drawing. You're going to draw this way, right? Keeping the string tight. Can you picture that? Tight as you go this way, and then same thing go down here, you'll get that egg shape. You see, those two focus points generate the picture. They are what produce the picture. What are they? They're all these edge points. All these edge points, which become our ellipse, are all the points that you reach by making the string tight as you draw around. You don't let it be loose, right? You hold it tight. Well, what does that mean, hold the string tight? Well, you know what? The string's total distance is fixed, whatever it is. I don't know, however long that string is, 10 inches, whatever. That means this length plus this length is a constant total of 10. That's what it means to hold a string tight while you draw. Mathematically, that means whatever this length, call it A and B or Joe and Tom or whatever, A plus B is a constant 10. It's constantly the total length of the string. In other words, the ellipse, what an ellipse is, it's the set of all these dots. All these dots, why do they get to be on the ellipse and this dot's not on the ellipse? Why? Because all these points are all the points that have the total distance from your two focus points, C and negative C, equal. All the points have the same total distance. Like however far this is plus this, maybe this is 5 and 5. Maybe this point is 3 away and 7. I don't know, I'm just making numbers. Just to show you, they're all 10, maybe. Or, yeah, because I said 10. You know, at this point, maybe this is 2 away and this is 8 away. Whatever. All the points, if you add up how far they are from one focus point and the other, it's always going to be the same total. That's what an ellipse is. The set of all points that have the same total distance from the two focus points.
What is that called, that distance?
Equidistant. It's just the same total distance. So that's what it is. That's why we're into these focus. The focus points generate the shape. So you ever seen somebody do that? They bring in a board with 2 nails and a loose string, and they pull it tight, and then they draw, and they get the ellipse. It's the set of all points that have the same total distance from the two focus points. So that's what it is. You don't have to do anything with that. It's not going to be on a test. That's why I usually don't spend time. Since I'm doing that, how about what was the parabola? Like, where'd the parabola come from? Why did he have a focus point? Well, what the parabola is the set of all points that are equidistant from a focus point and the directrix line. That's what that directrix line was all about. If you said, hey, I want you to show me all the dots that are equidistant, equal distances from this focus point and this line. What are all the points that are equal distance from those two? Well, how about this point right here? He's right in the middle between the line and the point. Okay, well, so is this guy and this guy and this guy? No, they are not. Why not? How far is this guy? So say this is, I didn't draw it very well. None of them look equidistant. Maybe it's right here, my drawing problem. Suppose this is, I don't know, 5 away, and this is, I'll just make up numbers, 5 away. So this point is equal, he's right in the middle between the line and the point, right? But this point is not. Why not?
Because it's higher.
Yeah, he's 5 away here. He's 5 away from the line here, but he's further away here. He might be 6 or 7 away from the focus point. He's still only 5. He's not in the middle, is he? He's closer to the line than he is to the point. So what does that mean? So he won't work. What do you got to do to make the dots continue to work? You got to go to the right a little bit. Maybe not quite that far. A little bit. Come on. But right there, right? Now he's maybe 6 and 6. They're not the same total, but they're the same distance. It's not like the ellipse, which was add them up, same total. That's what ellipse was. Add them up, same total. 7 and 3, 5 and 5, 2 and 8. Add them up, same total. Total string length. This is equal to each other, whatever they are. They can be 10 and 10. Equal to each other. We see what you're going to get? All these points. Like you think this point? Yeah. He's maybe, 7 from him and 7 from him. I'm probably not drawing it very well. But that's what it'll be. That parabola shape is the set of all the points that are the same distance from the focus as they are from the directrix line. That's the generation that what produces and generates a parabola. That's why that satellite dish does what it does and aims everything at the focus. All right. Anyway, that's the theory behind it all. Let's get what you got, Taryn.
4x squared plus y squared equals 64.
Thank you. All right, that's number 4, right?
Yep.
All right, so probably want us to graph it and find the focus points and vertices and vertices and stuff. So anyway, so what should we do? So here we have an equation. What should we do? So let's just start with the graph. I think the graph's the easy place to start, and everything else kind of comes from that pretty easily once you have the picture. So how are we going to get the picture? Something's wrong with the equation as it currently is.
Divide by 16.
Yeah, I got to get a 1 on the right. Is everybody catching that? So just like the 4 was really important on the parabola, we had to get that 4 because then you had the A right next to it, which is where the focus point was inside the satellite dish, the receiver, right? For these guys, for the ellipse, and same thing, 10.4, so this whole week, it's all about getting a 1. These last two sections, 10.3, 10.4, ellipse and hyperbola, it's all about getting a 1. So you must get 1 on the right side. Well, that's easy. If they just give you some number over there, just divide by that number, huh? And you've got to go all the way across, of course. So that's 1. What happens over here? Well, you divide, just use your calculator. 4 goes into 64, 16 times. And the other one just stays that way. Is that good? So now we're ready to draw the picture. So once you get the 1, then you can just do the normal stuff to get the picture. So, okay. Can you draw the picture from there? So go ahead and draw an ellipse. Doesn't need to be perfect or anything. You don't need to show all the marks. Just draw just figure out first off, is it taller or is it wider, and then put down the 4 edges. So is this one taller or wider? It's taller. Whatever's underneath y is bigger. So it's more up, down. It's up 8, down -8, square root of 64. And it's right 4, left -4, square root of 16. Good? So here we go. So again, I think these are easier than probably because we don't have to worry about right, left, up, down. Okay, so and then the 2 focus points. Well, what's the major axis on this one? Up, down, or right, left? Up, down. The y-axis is the major on this one. And that means the focus points are going to be on that. Can you picture the 2 nails with the pencil and how it would draw? Right? They must be up-down nails to make it taller than wider. So there's the 2 focus points. I mean, somewhere on there. How do I find them exactly? The Pythagorean with the minus in between. So that's called the foci equation. We're going to have the same thing when we get to hyperbola, except they're going to have plus in the middle. They're going to reverse the sign on that too. It'll be Pythagorean exactly for hyperbola. So that's what we use for focus. And remember, the C is the focus. Everybody with me? That's different, huh? For parabola, we used A as the focus point. So I don't want you to be confused by that. Everybody see that difference? For parabola, we called it 4ax. Y squared is 4a. And A was the focus, wasn't it, for that section? But now we're calling it C in this section, and the A and the B are what's underneath the x and the y, aren't they? Okay, so when I plug them in, which one am I going to put first?
61.
Yeah, the bigger one. Don't worry about if it's x or y or whatever. Just put the bigger one. And the smaller one equals c squared. Subtract that. 48. Yeah, that's right. And then root it. I don't know. Do they want? Do I need to simplify that root? Probably, huh? Do you remember, Taryn? Have you looked or anybody else? Do they want me to? They want me to simplify that root 48, don't they? They don't want a decimal.
Yes.
I don't think. They want whatever that is.
And they also want the vertices.
They want 4 root 3, right? Yeah. So remember how to simplify square roots? Square root of 48. Yeah, and I know I got to get the vertices too. Yeah. So break that down. Use your calculator. Divide by 4. It's 4 times 12, isn't it? Yeah. 4 times 12. 12 is 3 times 4. Bless you. So there's a couple of 4s. Remember, whenever you have 2 of something in a root, you can send 1 to the front. It's basically, I tell my algebra students, square roots are a 2-for-1 deal at Target. 2 in, 1 out, right? For 2, you pay for 1. So 4 root 3. So that's 4 root 3. Remember all that kind of stuff? So this is 4 root 3. So that's C. C is 4 root 3. So that's where the focus points are. So that means this is over 0 up 4 root 3, and this is over 0 down 4 root 3. The 2 focus points. They also want the vertices. Yeah, let's put that on. This is over 0 up 8. This is over 0 down 8. Remember, the vertices are the longest edges. So they don't want the right left points. They don't want the 4, -4. Those aren't vertices on this one. The vertices are the longest edges. So this one, it's top and bottom. And that's probably all they want. Is that good? Questions? So it's all about getting a 1. And then use the focus equation. C is the focus. Okay, there it is. So number 3. Wait,
6.
Bless you.
I'm not sure what happened. Let me try that again. Boom. There we go. Number 6, thank you. Number 6. Okay, find an equation for the ellipse. Center 0, 0, focus 0, -8, vertex 0, 10. like I said, in all of these, this whole chapter, I think it's really helpful just to start the picture. Even though really all they want is the equation, the picture's very helpful. So let's get a rough look at the picture. Center 0, 0. Focus is 0, negative 8. Vertex 0, 10. So focus, remember it's over, and so over 0, down 8. That's one of the focus points. So where must the other focus point be?
0 positive.
Yeah, 0 positive, because the center is 0, 0. So there's the two focus points. And then they're telling me the vertex, which means the longest edge, is at 0, 10. So here's the vertex, 0, 10. And the other vertex, 0, negative 10. And is this shape taller or wider?
Wider.
It's got to be taller because the vertices are up and down, aren't they? And so are the focus points. That's the major. The major axis is always where you find the focus points and the vertices. So I don't know how wide, that's terrible drawing, but I know it is taller than it is wider. I know that much, at least. Okay, so now they want the whole equation. So they want like the x squared over a squared plus y squared over b squared equals 1. They're giving me the equals 1, so they just want the left side. So how do I find the left side? So what do I know already? Right away I know something. What do I know?
Y squared.
Good, yeah. Again, don't worry about whether it's called A or B. The Math Excel will make a big deal about all that. But you just think, hey, look, I know how far up. I know it's up 10 to the edge and down negative 10. Up is y. It's underneath y. Up, down is underneath y. So it's y squared over 10 squared, 100 in other words, right? Just make that 100 or leave it 10 squared, doesn't matter at all. Either way is good. Now we have to find the a squared, or whatever's underneath x. Call it whatever you want. I got to find that one. How am I going to do that?
100 minus 1.
Going to use the focus equation because I have the focus point. So we're going to use the focus equation again, the foci equation, which is what? A squared minus b squared is c squared. Now here it's going to be a little tricky. Going to need to be careful in your thinking. Not, be careful. Don't just kind of blindly plug things in. Because if you let me show you what would be wrong. It would be wrong to go, okay, let me see. C squared, what is c, first off?
What?
That is the 8. Yeah, that part's right. The c is the 8, right? C is the focus. C is always how far to the focus. So that's 8 squared, 64. That's true. That part's correct. That's nothing wrong yet. But here's the part that's wrong. It's to go, okay, b is 10. That's not true. And so I'm looking for a. That's wrong. Now, why is that wrong? I mean, b is 10 right there. B is 10. Well, remember, I'm being loose with a and b because I think it's easier. I'm trying to make it easier for you. Math Excel, I think, gets all uptight about a and b, and they say, oh, no. So this is really this, but it's really a here, and then all this stuff. No, I mean, they're right. Yeah, okay, they're technically right, but it's just hard to track all that. Instead, remember what I suggested you do when it comes to the focus equation. What one thought it will be helpful, so you won't have to worry about all the A and the B and the switcheroo. When you subtract two things, who has to come first?
The bigger number.
The bigger number has to be first when you subtract two things and get a positive answer. And so, okay, so which one's bigger? Up, down, or sideways?
Up, down.
Up, down's bigger. Call it whatever you want. I know up, down's bigger. So whatever's underneath y, up, down, is the bigger. 10's got to go in the front. And that will change your answer. That's not irrelevant. So technically, this is B in this case, and this is A. But again, I wouldn't worry about all that. That's where Math Excel, they say A's always under the bigger one, and all that kind of stuff. Does that make sense? Do you see that? That will definitely change the answer. You gotta watch that. So remember, whenever you write the subtraction of any two things in a math formula, the order matters for subtraction, doesn't it? We have to put the bigger one first, and we know where the bigger one's the up down. It's what's underneath y. So 10. This other number has to be smaller than 10, doesn't it? We know that because this thing is not as wide as it is tall. The major axis is up down because the focus points are on the vertical. They're up down. Okay, so then solve this. So this is what, 100 minus b squared is 64. Subtract 100. So minus b squared, remember that it does have a minus on it, right? Is minus 36, so that means b squared is 36. Root it. B is 6, so this is 6 squared. We're done. You can just leave it that way or make it 36 and 100, whatever. So I think math is going to take it either way. See how the x was less? And it makes sense the x is less on that one. It's less wide than it is tall. Is that okay on that? Questions on that? All right, I'll keep moving. Okay, so number 8. I'm going to try that one. Center 0, 0, vertex 0, 7, B3. So I would definitely start. The graph just helps. I think it just really helps to see something, you know. So just start putting stuff on the graph. Center 0, 0. And so 0, 7 is a vertex, so the other one's got to be 0, negative 7, huh? And right away, does everybody see? Right away, because they are saying those are the vertices, the major axis is up, down. Remember the vertices are always on the longest axis, aren't they? So that means I know the focus points are somewhere on this axis also. I know this thing is taller than it is wide. My drawings are getting worse. Taller than it is wide. I know all that just because the vertices are up, down, huh? Is that good? So then what's this 3 thing?
That's B.
Yeah, that must be how far over. It sure doesn't look like it on my picture. But that must be how far the sideways are, huh? Good? See how I know all that? And I know the focus points are up, down. How do you know? Because the vertices are not all 4 edges. They're longest edges, aren't they? So it's longer top and bottom, and the focus points are always on the major axis, the longer direction. Okay, so can I find the focus points? Yeah, use the focus point equation, which is Pythagorean with a minus. The focus is the C. A squared and B squared? What's A squared and a B squared? 7 and the 3. Right, it's 7 up, it's 3 over, right? And the bigger one has to go first, doesn't it? 7 has to go first. So 49 minus 9 is C squared. 40 is C squared. Root of 40. That's 4 times 10. Square root of 4 is 2. 2 root 10. C is 2 root 10. And we're done. You can answer all their questions based on that. Is that okay? All right, I'm going to move along. I'm going to try to... Oops. I can't see it for some reason. Is it here? Where is it? There it is. Okay. Number 9. All right, so let's try that out. So they want the equation. So they give me a picture. They want the equation. This one is not centered at 0, 0. It's over 3, down 1. Can you all see that? That's the center. Now, remember what we learned about the center for parabola? It's the same thing here. Remember, whatever numbers are the center of any of these shapes, it's opposite, 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 opposite. That continues the case all the way through. If you go up to Calc 1, 2, and 3 in three-dimensional space, you got these egg shapes that are 3D, and it's the same rule. It's just opposite of the center. So we know somewhere in our formula we're going to have an x minus 3, we're going to have a y plus 1 with parentheses somehow in our formula. Does that make sense? So he's the opposite of whatever. If you have positive 3, it's minus 3, and that's x. And the y, it's going to be opposite plus 1. Always. So, okay. Other than that, just try to do the regular. What do I mean regular? It's normally x squared over a squared plus y squared over b squared is 1, except instead of x, I'll have what? X minus 3. Instead of y, I'll have y plus 1. Good so far? That takes care of the center. That's all you got to do when they move the center. It's pretty easy. It's just opposite, opposite. Because remember, if you plugged in, that would make it 0, 0, wouldn't it? Okay, so now we got to find the A and the B. What are the A and the B again? They're always how far, huh? So in other words, from here to here, that's going to be A. That's going to be whatever's underneath X, because it's sideways. So how far is that? This is like 3, and this is, what, 7? So it's 4? A must be 4. So that's what it is. So A is 4 squared. And then B is the, from here to here. That's B, right? Because middle to top, that's just 1, isn't it? Yeah, that's just 1. So B is 1. And there we go. We got the equation. So A is just how far from middle to edge. B is just how far from middle to top.
If it's on the axis, if it's on the x-axis, I'll tell you later. I'll ask you later.
Sure. So there we go. All right. Okay. So they start off, they say, hey, give us the center. They call it HK is what they usually call it. So can you tell what the center is? Remember, it's opposite, opposite, right? Opposite, opposite. So it's going to be positive 1, negative 4. Good so far? That's the center. Let's start drawing. It's always helpful to draw the thing. Over 1, down 4. There's this. Always start with the center. There's the center of the shape. Okay. Now, to draw this picture, there's the center. Is this egg-shaped ellipse going to be wider or taller?
Wider.
Yeah, because what's underneath X is the bigger number. Square root of 49 is going to be 7. So that means it's going to be right and left 7 from the center. Right 7, left 7. So I'm going to go to the center here. I'm going to go right 1, 2, 3, 4, 5, 6, 7. I started at 1, I'll end up at 8, won't I? Is that good? 7 to the right, and then I'll go 7 to the left. So starting here, 1, 2, 3, I'm going left. 4, 5, 6, 7. Let's go 8. No, 7. 7, that's it. Boom, this is at minus 6. Everybody see that? I went back 7. So from the center, I went right 7 and left 7. Does everybody see that? Let me give you a way, because this gets messy with all these coordinates. Now that they're from the rest of the way, the rest of the second half of this section, or even the last 2/3, are all going to be not centered at the origin any longer. They're moving them on us. Here, let me give you this help. I'm adding 7 and subtracting 7 from what? From the x. That's what you're doing, huh? 1 plus 7, 8, negative 4. 1 minus 7, negative 6, negative 4. That's the easy way. Just take the coordinate that you're moving, which is the x coordinate when you're going right and left, and just add 7 and subtract 7 from the x number. Right? Add 7, it's 8. Subtract 7, it's negative 6. And then you got to go up and down. So now up and down is 2, square root of 4, 2. And that means up and down affects the y coordinate. So take the center and add 2 and subtract 2 from the y coordinate. Remember the y coordinate here, let me make it a little cleaner, was negative 4, wasn't it? So when I add 2, negative 4 plus 2, that'll be minus 2. So that's right here. The x coordinate doesn't change. Over 1, down 2. And then the other one, subtract 2, minus 4 minus 2, it'd be right here, 1 minus 6. And there's our shape. Oops, sorry. My drawing is terrible. There is the egg shape. Does everybody see how I got these coordinates? Right? I just added and subtracted to the x, and then added and subtracted to the y. So then, okay, got a minute left. Last thing, they're going to ask me for the focus points, I assume. Where do we find, at some point they will, where do we find the focus points? Are the focus points on the sideways or the vertical? Sideways, because this thing is wider than it is tall. So they're going to be somewhere on this line, aren't they? Right and left of the center, whatever C is. So you use the A squared minus B squared is C squared focus equation. The A and the B are the 49 and the 4. A squared is 49, B squared is 4. So 43. So C is the root of 43. Can't simplify that. Okay, so what do I do with that root 43? I take the center. Let me bring it up here. I take the center.
Yeah, I was saying 45.
45?
Oh, it is. Thanks. So I can simplify that. Trying to go fast. So that's 9 times 5. Root of 9 is 3, so it's 3 root 5. So 3 root 5, I add 3 root 5 and subtract 3 root 5 from the x coordinate, because it's right, left, right? The focus points are right and left. So the two focus points then are 1 plus 3 root 5, comma, negative 4, and 1 minus 3 root 5, comma, negative 4. There they are. And we will